It is Thursday, April 10th, 2025. The future is like the blank paper on which we can write and draw whatever we want. So please remember that. Like, whatever the future holds, you can do something fresh and new. And so if you haven't been handling business, you can start handling business. So just know that. Like, don't get stuck into like, oh, we're halfway done, it's already too late. No, it's not too late. You can take this time to do work, handle business. All right, y'all. Let's just stand on business at the very beginning here. A couple of things before, and I'm not going to take the time in this video to do the timer, but in class we're going to take 10 minutes. So please take 10 minutes to stand on business. Okay, so you know what I'm saying? Hey, boom. Okay, so take 10 minutes to do that. So make sure you turn in your CER. Some people had an issue with turning in the rough draft. You can turn in the rough draft and the CER separately, totally fine. It doesn't bother me any. Then make sure to go to Canvas grades, make sure you're good. Also make sure that you finish the ed puzzle. A lot of people said the ed puzzle was easy. However, we only had about a 70% turn-in rate, and I believe I attribute that mostly to I'm hoping that people just didn't finish the video all the way. If you don't finish the video all the way in the ed puzzle, then it will not give you the credit. So make sure that you handle that business. Give people 10 minutes in class to do that. You pause the video, take your 10 minutes, handle what you need to get handled. If you got everything done, then you can just move on in the video. We're going to keep it going. All right. Next thing is oh, this thing didn't work out the way I thought. Hold on. All right, now we are good. So dress coded. I do want to say this. Just remember, there's two different things about the dress code. Some people are like, I don't think it's fair. Okay, this is true. You may not think it's fair and you may not like it. That's fine. But liking the dress code, right, and agreeing with the dress code is one thing, but actually complying and following the dress code, these are not the same thing. So I don't have to like the rule in order to follow said rule. So understand that. My kids all together as a whole, they got dress coded one time. I got 4 kids. My last kid is a senior in high school right now. 1 boy, 3 girls. They got dress coded as a total one time. And the reason for that is because my daughter had a matching shirt and socks, and you couldn't have 2 pieces of clothing that matched the same. Hey, it was the rule. Do you think we agree with the rule? No. However, once we were like, oh, that's it, and we can't do that, okay, then for sure we will comply with the rule, even though we don't agree with it. So just understand that. Now, here are some of the major violations, and when I say the major, they're not major in the sense of big, they're major in the sense of number. So the number of people having these issues. So the short shorts, the crop tops, the sagging pants. Look, the sagging pants, let's just keep it real, okay? Buy pants or get pants that are the size of you, or get a belt. You got options, okay? And people are like, what if I can't afford that? I'm like, yo, your jeans cost $100. Okay, look, I know some people might be able to afford it. If it's really an affording issue, please come talk to us. We'll help you figure it out. But definitely get a belt or wear pants that fit you, okay? Number 2, the crop tops. Let's just go with this. Most people aren't wearing like a real crop top. What most people are doing is they're wearing a shirt that is right on the edge of where your waistline for your pants are at, or your shorts, and then as soon as you put your hands up, boom, now we can see all kinds of skin. And I'm like, yo, wear a shirt that if you lift your hands up, we should not be able to see any of your skin there. So just understand that. So there's no crop tops. And then shorts, just look, use a good rule. I think they're saying somewhere in the, like, if you put your arm down, it's about to your hand. So just figure that out. And if you're on the edge, when you're in the mirror, this is a good rule of thumb just in general. If you're in the mirror and you're like, I don't know if this meets dress code or not, it probably doesn't. Let's just keep it real. It probably doesn't. So let's just keep it for what it is. Also, make sure to put on deodorant. Come on, fam. It's getting hotter. People's dress is going to be different. Also, your smell is going to be different. So please make sure to use deodorant. If you're like, yo, Mr. Farr, I ran out. I just need a quick little spray. I got you. You know what I mean? I got spray on deodorant. Also, if you're like, I don't have deodorant, but I need deodorant. Most students told me that they do. They have it. Please just, have some in your locker or have some in your bag. Just use that and handle the business. Love y'all. Let's move on. Okay. I do want to say this. We are having a journal check. This is next week. So this is for next week. So we are having a journal check on 4/16. So understand that. So we got your guys' journals kind of updated like earlier this week. So we should have got that updated. We do got some notes we're going to take and things. But however, I just want to make sure that you guys know that we are having a journal check next Wednesday, because next Friday we do not have school. So we're going to have the journal check next Wednesday. So holla at that. Okay, let's keep it pushing. Also, you will memorize the first 30 elements of the periodic table. You will take a test on that after spring break. You will make flashcards for the first 30 elements of the periodic table, and those flashcards will be due on Thursday. People are freaking out. Relax. Once we read through them, you'll realize, oh, I know a grip of these, probably at least half already off the top of the dome. Okay, cool. Now we can start to the memorizing of the ones I don't know. So I'm just telling you, these are very common, just like you see right here. This one right here, you could probably guess what that is. Hopefully you can guess. Hopefully you guessed it was helium. Over here, what do you think this one might be? Oh, hydrogen, right? Because it's a hydro flask. Cool. So we'll make cards like this that'll make it easy for your memory. Trust me, and then we'll use them and show you how to use flashcards, okay? So don't trip out. I'm just putting this stuff out there because some people are going on vacation on spring break. So let's keep it pushing. We're not going to do that because we do not have time for that in this class. So we're going to keep it pushing. However, we're going to talk about the states of matter. Hopefully this is review for you. If you look here, this one is, hopefully you know it, and it's a solid, right? So it is a solid. And if you look at the structure, very strong, rigid bonds. So the bonds kind of stay in place, and that's what helps a solid, right? Like this bubble gun right here. That's how the solid is able to keep its shape, because its bonds are very strong and rigid, and they don't change. So they usually have a design like this, and that's what helps it to keep its form and from not losing that form. Now, as you move on to the next one, the next state of matter is juice. No, it is liquid. And a liquid, right, its bonds are, I would say, medium to weak, right? But it's not like they're super weak. So let's just take a look at this, and you can see this. It's just like when you pour something out, if you look, like, they don't just break because of gravity. They actually, if you see, all the water is pooling together. So those bonds are fairly strong. And then this is the thing. The bonds can break and reform fairly easily inside of a liquid. So if you look inside this beaker right here, right, all of the bonds of all of the liquid have reformed again inside of here. So even though some of them broke when it hit the beaker, they have reformed back in here. So for a liquid, the bonds are medium to weak, right? However, they can break and then reform very easily. But as you saw, they do like to stay together. So it's not like they're extremely weak. So even coming out of there, they were staying together. Okay, next thing that we have is gas and gas bonds. Hopefully you've guessed this, that they are extremely weak and they will just break. That's why gas just travels in all kinds of different directions. That's why if you let like the helium out of a balloon, it just goes out and it just dissipates out, right? Because the gas is just going to move in all kinds of directions. All right, and then the last one, maybe you don't remember or not. We talked about this earlier in the school year, but it is charged gas, right? And that's going to give you this thing called plasma, right? And so this plasma is these charged ions. That's why they call it ionization. So there's these charged particles, or these charged atoms, right? Or these charged molecules that are in the air, right? And since they have a charge, plus and negative, that allows electricity to flow through them. Hence how we get lightning to be able to be in the air, okay? So we kind of took a look at that. All right, let's keep it pushing. Now, what is matter? So as you're looking at this states of matter and how they go back and forth between them, what is matter? So we asked what are the different states matter can exist in, right? Because these things are matter. And if matter can be a solid, liquid, or gas, or plasma, then what is matter? Remember this, okay? And write this part down. Again, pause it and then write this down. Matter is anything that takes up space. That means it has volume, because volume is the amount of space an object takes up, the measurement of that. So matter is anything that has volume or takes up space and has a mass or weight. So if it has a mass slash weight. I shouldn't say mass or weight. If it has mass, then it has a weight. So anything that takes up space or has a volume, and anything that has mass and then therefore it has weight. By the way, some people are like, what's the difference between mass and weight? The difference is this: mass is a measurement of how much atoms or things or molecules an object is made out of, right? And weight is how gravity pulls down on that mass. Now, the way that I remember that is this G right here. So weight has to do with gravity. Okay, let's keep it pushing. Pause the screen if you need it. Pause the screen if you need it. We're going to keep going. So tell me what you know about the periodic table. Obviously, we're on a video, so you might have told me some things like there's elements, there's atoms on there, there's a whole bunch of numbers. Some people said, oh, it's in columns. Like, I see some things that I know, like oxygen over here where that O is at, fluorine, there's neon, there's things that I know on there. It's about all I know about the periodic table, right? Now, we're going to talk about this in particular. So remember this about the periodic table. It's the periodic table of elements, which means you will find atoms on there. You will not be able to find molecules. I asked some people, could you find water on there? They were like, looking and looking, and then they were like, no, you can't find water, and that's correct because it's the periodic table of elements. But if you're thinking about each periodic table square, it actually is going to tell you about one atom of that element. So one atom of carbon, this gives you some information about that particular one atom, not a molecule, because a molecule, and we'll talk about that more later, is actually two or more atoms bonded together. So that's what we get in H2O. We actually have 3 atoms bonded together, 2 hydrogen and 1 oxygen, H2O. Okay, let's keep it pushing to the last note of the day, and here we are. I'm going to walk through this slide. You pause it as you need be. So at the top, you see the element name, carbon. Now, you will not always see the element name at the top, and sometimes the periodic table does not even have the names on it, okay? Check this out. If you look here, it looks very different than the layout I was just showing you. See how carbon, you see the symbol is above the name. So sometimes it's going to be different. Also, this one has so much more information on it than the one that we're showing on the screen. So if you look, you have to read this table. Like you're gonna have to read this table and then read all the different things to tell you like what it is. And then this one also has all these different colors, and that's because over here it's telling you like, yo, this one's usually a solid at room temperature. This one's usually a liquid. This one's usually a gas at room temperature. This one is artificially prepared, which means it's prepared in a lab. That's what all the different colors are. Now, this periodic table is in your agenda. This is the one we're going to mostly use. Now, back to the notes. All right, cool. So, again, right, the element name is carbon, and it's usually at the top, but obviously sometimes it can be located in different places in the cell. Now, almost always at the top, you will always see this. This number will always be at the top somewhere, right? I can't tell you where it's going to be left. It's usually left or center, but sometimes it could be right. Atomic number. So this atomic number right here is the number of protons in the nucleus of the atom. Hopefully you're cool with the nucleus, because that's at the center of a cell, right? Also, it's at the center of an atom, and that's where the protons are located. Think of the atomic number like its social security number or its ID number. This number only belongs to carbon. If the number of protons changes, then its atomic number changes, which means it is no longer carbon, okay? Let's keep on pushing down here. So the symbol, right? The symbol is usually a shorthand abbreviation for the element name, and most of the time it matches. There are some that do not match, and the reason they don't match is because they had a name previous. They had a different common name that was all over the world before we had the periodic table, and because of that, they have incorporated that into some of them. Okay, so just realize that. So again, the symbol is a shorthand abbreviation for that, and here I'll give you an example, right? Let's just take a look at, let's go right here, FE. Boom, it's iron, and that is because I believe this metal was originally called ferrium. So we usually still use this today. If you get a metal detector, it detects for ferrous and non-ferrous metals. So it's saying iron metals, ferrous, and non-ferrous metals could be like silver or gold, right? So again, sometimes they do not match up. Last thing is the atomic mass. This is the average mass of the atoms in this element, all of the different versions. So we haven't gone that deep into it, but as you can see here, this says 12, so there's a carbon 12. There's also a carbon 13. There's a carbon 14 as far as the mass, and these are AMUs. Just so you know, atoms have to have their own way to measure their mass because they are so small that any scale that we had before was not useful. So we had to come up with atomic mass units, right? That's what the AMU stands for. So it's 12.01, and on most periodic tables it's usually 12.011, right, is the AMU for carbon. And this is how you can tell which one is the most common, since it's an average of all the different types of carbon. If you rounded this to the nearest whole number, you would round to 12, which means carbon 12 is the most common version of carbon. It also probably tells you it's the most stable version. That's why it's the most abundant on Earth. All right, y'all, that is it for today. Peace.